Welcome. We're in London for this year's ESC Congress, and I'm here with Dr. Haitjema, who is Principal Investigator of the NextGen Consortium. My name is Ima. I'm from Utrecht in the Netherlands. And good morning, Saskia.
Good morning.
Nice to meet you.
Nice to meet you too.
So, NextGen, what is it? What is it all about? Can you tell me something about it? Can you give me some information?
Yeah. So NextGen is a European research project that was awarded under the Horizon Europe program. It contains 21 partners and it's funded through the European Commission, UK Research and Innovation, and the Swiss State Secretariat for Education, Research and Innovation. When we think about a one-liner to define what NextGen is, it's basically a research project that's dedicated to building tools to enable portable, multimodal and multiomic research for personalized cardiovascular medicine.
Sounds very interesting, but also like containing a lot of hype words, which I like to hear more about it, like multimodal. Can you maybe, explain a bit more?
Sure. So let's start at the multimodal. So what multimodal basically means is that you try to combine different modes of data. So what that means is you try to combine, when making a prediction model, for example, EKG data, which is of course very different from laboratory data, which is very different from imaging data, and we try to integrate that into one model. So that's what multimodal means. To multiomic. So what that means is, omics is always related to the identifying characteristics of an individual, which is related to, of course, your DNA. So when you talk about DNA data, you're talking about genomic data, but there's also lots of other omics data. For example, if you look at a protein, individual protein levels, you call that proteomics. So that's the multiomics. We look at different levels of those omics data in an individual to better predict cardiovascular outcomes.
And what will be like the core innovations of NextGen, and so how is that going to propel the field?
Yeah, so there's basically three different tools that we're going to build in NextGen. So first one is related to the portable I mentioned before. So what we mean by portable is that often when we do research, of course you develop something in one site and then you have to sort of validate or implement it on another site. But that's very difficult because sometimes the way these data are coded are different from one site to the other. So we're building adapters, so that's a large part of the project. So one of the tools is basically building an adapter to make the research portable from one side to the other. And what's the interesting part about these adapters, because a lot of people are working on these types of adapters, so we're building them specifically for genomics or these omics data. But more importantly, we're also looking at the regulatory framework of the different countries and building that into the adapter. So you know from one data set to the next what you can use for what reason that you want to use it for in that country for research. So that's the portable tools that we're going to make. So another thing that's very innovative is that we're going to build federated learning tools for genomics data. So again, a lot of people are working on federated learning. So what it basically means is that different from you pooling every data that you can find together in one data set, you're going to leave the data in the different countries and the different partner sites, and you have the algorithm travel along the partner sites to basically visit the data. So you do not have to pool all the data. And these tools are available, but often they're not specifically built for genomic data or for omics data. So we're gonna add that. And then for the third one, which is also related to genomics. So a lot of genomics pipelines take a very long time because genomics data is very big. So you need a lot of pre-processing basically to be able to use genomics data. And we're going to make those more efficient. So then you have to think about variant calling or that kind of stuff that we're going to make, more efficient, hopefully.
Okay, I hear two important words actually. The first is implementation, the second one is use. So how are you going to actually translate those core innovations into actual use?
Yeah, so thank you for that question, because this sounds very technical. So fortunately, we have clinical partners also in the consortium, and they helped us to identify the barriers that they need to overcome in their research. And based on that, we actually came up with those tools that we want to make. So there's clinical partners that have defined use cases, so they can use our tools and basically co-create, co-develop them. So they're of use in their research, and then you have to think about making prediction models or estimating treatment effects, making pipelines for cardiovascular disease prediction.
Sounds all extremely relevant, and congratulations to you and your partners in for actually achieving this this funding. I think it's a very important project. Of course, we're all very excited to hear. Can you already share something like first exciting results?
Yeah, I can imagine you're very curious about that. Well, we only started this January, so I hope next year at ESC we will be able to present first results. But for now, we're really just started. Yeah.
Well, I'm sure everybody is going to look forward to hearing those first results next year at the ESC Congress. Thank you very much, and congratulations once again. Thank you for listening and watching. Bye-bye.